Hi everyone. So in this video, we're just going to discuss the Leetcode problem today, and it was supposed to be a screencast solution, but I just figured out that I already had solved this problem, and I did not solve it today. I solved it this year earlier, right? So you see, it's 9/10/2023. So I believe that this must have been a repeat problem, or I must have encountered it somewhere. But let's just remove this for now. We're not going to talk about it. We are just going to write the fresh code and hope that it works as well, because the last time I did it, I got two wrong answers. So anyways, the problem is a medium level problem, and it is determine if a cell is reachable at any given time. Right, so we have been given four integers, and I believe they are sx, sy, fx and fi. So sx and sy are denoting the starting cell, and at each second we must move to any of its adjacent cells. Right, we have to return true if we can reach cell fx and fi exactly after t seconds, otherwise we have to return false. A cell's adjacent cells are the 8 cells. Okay, so that is cool. Now, now I remember where I encountered this problem. So I believe it was actually a part of some weekly contest. Okay, so the first thing that we notice is, can we in any way go to this particular cell? So the minimum amount of time that you require to reach any cell, right, any other cell, should be, let's say, first you will calculate the distance between the starting and the ending cells. So let's say the dx is absolute of sx minus sy, and dy is equals to absolute of so it should be sx minus fx, right? It should be sy minus fi. So basically what I'm trying to do is, I'm trying to find the distance between the x coordinates and the y coordinates, right? So let us first find out what is going to be the minimum time to like reach these cells. So it is going to be I believe maximum of dx comma dy. First of all, I'm just going to take minimum of dx comma dy plus maximum of dx comma dy minus minimum of dx comma dy. So okay, so can we just take maximum of dx comma dy? I'll tell you the reason why. So what happens is, let me just draw the grid once. So if I have a grid, 2D grid, let's just say you are at this point and you want to reach this particular point. So what is the total distance that you would want to travel? The distance will be equals to 1, 2 and 3, right? So the total distance or the total number of seconds that you took was 3 seconds, 1 here, 2 here and 3 here. Now if you moved one step to the right, the answer, let's say, how is it going to change, or is it going to change? The answer is going to be 1, 2 and 3. The answer is still 3 because the difference in the cells is 3. Now if I change it to this particular position, you will see the answer is going to increase by 1. Why? Because now I have to go one extra step, 1, 2, 3 and 4. So the value of dx here was 4 and dy here was 1. So you see the answer is ultimately depending on the maximum of both of these values. So we have got a lower bound on which we can go to this particular cell, right? If the timing is less than this particular value, then we can never reach the cell. So what we can do is, if timing is less than minimum, then I can just directly try to return 0. This thing is for sure. Now let's see what happens. So we have to tell at after exactly t seconds. So let's say we reach any cell adjacent to it. So we wanted to go here, but we have reached here. Now what we can do, we can move here and then go here, right? So we have reached here. If we have exactly 1 second left, I would say that we can go here. If we have 2 seconds left, I would say I would go here and then here, and then again 3 seconds left, I would go here, here and then here, right? So I believe for any time value greater than this particular value, we can obviously reach the cells. and let us just check some sample test cases for whenever it is false. So in this case you will see that the maximum is going to be 4 and the time is 3, so it is false. Can I just directly return 1 here? So I am just trying this part. I know that if the time value is less than this maximum value that I have minimum value that I have calculated, then obviously I cannot reach those cell or the final cell. But what if the time value is greater than or equal to the minimum value? If it is equal to the minimum value, then obviously I can reach, but what if it is greater than the minimum value? So if this is the final cell that I want to reach, if I have reached any of its adjacent cell, let's say at time t minus 1 I have reached any of its adjacent cell, then I can definitely visit this final cell. If I have time t minus 2 I have visited any of its adjacent cell, then I can go to here in one step and then here. If I am at time t minus 3, then I can go here and then here and then here. So it is working for all those cells. Okay, now what if the starting and the ending cells are same? Okay, so we have this one last test case. Definitely you can reach here because you will always be able to enter this cell. But if the starting and the ending cells are same, in one step you cannot reach, right? You will need at least 2 steps, because if the starting and the ending cells are same, the value of this particular minimum would be 0, right? And if this number of steps is exactly equals to 1, then in that particular step you will just step outwards of this particular grid, right? You would need at least 2 steps to come back to the final cell. So let me include this final condition as well. If not dx and not dy. So basically this is the same condition that I wrote earlier, but this time I was able to figure it out, and the condition is t is equals to 1, right, or t is equals to 1, yeah, because if t is equals to 0, then definitely we can reach the cell. And let's just try to uh, compile it, and then we'll see what happens. So this problem was actually a part of a Leetcode weekly contest a few weeks ago. I remember this problem. So I also made 2 wrong attempts that day. Yeah, so we have accepted, and I believe this is the same way I did it earlier also. So I'm just opening it. So it's, you see, it was done 1 month ago. Yeah, so it's the exact same thing. Now let me just quickly summarize what I just said. First of all, this part must have been very clear to all of you that that this is the value that is the minimum time that it would take us to reach the final cell. If the value of time that has been given to us is less than this minimum value, then obviously we can return 0. Now, if let's say this is the final cell and I have reached any of its adjacent cell, right? I have reached here. I cannot enter this cell because we have to enter it at exactly t seconds, right? So now if I have odd number of time left, then I can spend the even part like this and then the final odd part like this. For example, if I have 5 steps, so I can go 1, 2, 3, 4 and then finally 5 at the final cell, right? If I have even steps, then I can go 1 and 2 like this, right? So in any way you can reach your final cell. The only edge case is if the final cell and the starting cell are the same and the number of steps or the time value is exactly equal to 1, because in 1 second you can move out of this value but you cannot enter back to this cell, right? So this was one edge case that you need to consider, and this was all about this problem. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to subscribe to this channel, and I'll be trying to post more such videos as long as possible. So yeah, stay tuned for that, and until the next video drops, keep coding, stay safe, bye bye.